Welcome to Stat 400, Week 3 at the University of Bridgeport. This is the video part 2 of 3, where we will be looking at the R code required to be able to do t-tests and correlations in R. So, as usual, I'm going to be setting my work directory. I will be calling my library ISLR, where it has my data. I'm going to call my data OJ, which is the data I've been using since the beginning of the course. And now I'm going to do a few t-tests. I'm actually going to do 4 t-tests. Just to show you how you can test the same thing in different ways, and which way would be better than others. So I will be testing whether the mean of the sale price of Minute Maid is different from the sale price of Citrus Hill. I start out with my code, t-test, t.test, open paren, OJ $, OJ meaning the data, $, signaling that the next is a variable, sale price Minute Maid versus OJ sale price Citrus Hill, that is OJ, confidence level 0.99. Let's run this and see what we get, and let's interpret those results. Okay, so it tells me what data I use. We're comparing the sale price of Minute Maid versus Citrus Hill. It gave us a t-statistic, degrees of freedom, and it gives us a p-value. This is the p-value that we've been talking about. This is a very small number here. The p-value is less than 2.2 to 10 to the minus 16. That's a very small value. If I say that my threshold is 1%, I would say that I reject the null hypothesis that the two means are equal, and I will believe that the alternative hypothesis is true. And it's actually telling me, because I'm not too sure how I coded this, but so it's going to tell me what is the alternative. The true difference in means is not equal to 0. So if you subtract the mean of Minute Maid minus Citrus Hill, it is not equal to 0. That means they are different. This 99% confidence interval is referring to this. We are 99% confident that the true difference is between 0.12 and 0.16. In other words, that the true difference is between 12 and 16, close to 17 cents. And then it's giving us the means of X and Y, X first one, Y second one, Minute Maid, Citrus Hill. This was a good test. It said that they were different, but, and it gave us a confidence interval. So this was great. Now, the alternative hypothesis HA12 test is the mean difference between Minute Maid greater, is the mean between Minute Maid, the sale price of Minute Maid, greater than the mean of the sale price of Citrus Hill. I already know that the mean of Minute Maid is greater than Citrus Hill. Now I want to test, is it significantly different? So I'm doing this same t-test, same thing that I have up here. I actually pasted it right down here, but I added one more command, alternative greater. Let's run this and see what happens. I get basically the same result here on the p-value, but look at what it says, the alternative hypothesis. True difference in mean is greater than 0, meaning first one minus the second one is greater than 0. In other words, is Minute Maid greater than Citrus Hill? It's giving me a 99 confidence interval that it's saying it's only giving me one number because it's a one-tailed test. And it's saying that I'm 99% confident that the mean difference between Minute Maid and Citrus Hill, in other words, Minute Maid minus Citrus Hill, is at least 12.5 cents. Again, sample means. The next test, I put it here as something to show you that not to do. You may do it and find out, hey, what happened? Well, this is an example as a test that is not correctly structured. Because the alternative, same thing as HA12, except that the alternative is less. In other words, I'm testing that Minute Maid, that mean of Minute Maid is less than the mean of Citrus Hill. I know that's not true already, but let's test it and see what comes out. It's interesting to see that now your p-value is not a small value. It is 1.0, 100% due to chance. I would retain the null hypothesis in this case. And again, test poorly structured because I'm testing something that I know is not true. HA12 was probably the best test so far. Now for the best test that we can do is this one, which is just a t-test of one variable saying price diff. Price diff is the price difference, meaning Minute Maid minus Citrus Hill. I know this because of my variable definitions. We will see this in the next video. Let me run this, and it's just testing Minute Maid minus Citrus Hill, but this variable here is at the store level. So that's why I like this a little bit better. So at the time of purchase, people had Citrus Hill or Minute Maid to buy, but Minute Maid minus Citrus Hill at that store gives us this value here. So let's run this. It gives me a very small p-value, so I reject the null hypothesis and retain the null that the mean is not equal to 0. And I am 99% sure that the difference between Minute Maid and Citrus Hill is between 12.5 and 16.7 cents. Moving on. Let's do a correlation now. Correlation, core test of Minute Maid and Citrus Hill. Same variables. Let's just see if how much do they move together. I get a p-value, a very small value, 1.3 times 10 to the minus 6, very small. And I am confident that the correlation is between 0.08 and 0.2. The estimate, this is very important. So first of all, very important to know, is it significant? It is. And this is the estimate, meaning that as one price goes up, the other one is going to go up by, on average, 14 cents. This is a weak correlation, not a strong one. Strong, very strong would be 1.0 or negative 1.0. Probably starting at 0.6 or negative 0.6 and, again, greater absolute value. But this is a weak correlation. Okay, moving on. Now, if I wanted to test all my correlations together, I would get all my variables that are continuous into this small OJ. If I run a correlation on OJ, I get all these numbers. It's hard to see which ones are big, which ones are small. It's kind of, hard to see. If we want to visualize this, as you see this visualization here, install the package Coregram, library Coregram, and then just Coregram little OJ, where you only have continuous variables, and you will get this over here. Here you can see where dark blue, positive correlation, you can see the lines, dark red, negative correlation, and then you have the moderates and the lows over here. If you can see, it's actually very interesting that we have week of purchase is highly correlated with the price of Citrus Hill, and it's also highly correlated with the price of Minute Maid. So as time goes by, prices go up. Okay? As time goes by, here we have the discounts. Discount Citrus Hill and Minute Maid. It seems like the discounts for Citrus Hill go up a little bit stronger than the price, than the discount of Minute Maid. So again, interesting things that you can see in correlations. You can see the discount Minute Maid is negatively correlated in a very strong way with the sale price. So in other words, the bigger the discount, the lower the sale price. Also very intuitive. So next video, we will be exploring how to put this all into an assignment. Okay, thank you, and to the next video.